László Kovács. I'm leading the Industry 4.0 Technology Center of the Technical University. First of all, let me introduce our Technology Center in a couple of words. Our Technology Center belongs to the FIEC. This is a new organization unit within the Technical University. It's called Center for University Industry Cooperation. Beside the 8 faculties of the university, this new organization unit was established 4 years ago, and the goal of this organization unit to run research and development projects together with industrial companies, utilizing the knowledge of the professors, the creativity of students, and the infrastructure of the university. So we are here. We are closely working together with several faculties of the university, for example, the electrical engineering and informatics, the mechanical engineering, transportation engineering, and even with the chemical engineering faculty. Our center was established for the project. This project was financed by EU, and the goal of this project was to support the national manufacturing SME, small and medium enterprises, to prepare to the challenges of Industry 4.0. This project had 3 key phases. The first phase was demonstration phase. We intended to draw the attention of the SMEs to these technologies. We invited 1,000 SME, and the second phase was the development phase. The SMEs who were developed enough for this Industry 4.0 project, they got a complete training program. It was approximately 1 week for each person. And the last phase, the planning phase, was about to help these SMEs to create a detailed plan for Industry 4.0 investment. Our result was in the demonstration phase we received approximately 500 SMEs. The second phase we had 134, and in the last phase we achieved the 50 SME. Interesting thing why we were not able to reach 1,000 SME. We just realized that even if this project was free for the SMEs, just to learn these technologies takes time. And for one person who attended this whole project or training pass, needed 10 days. So if a company spends 3 person for this program, that took 30 man days for that company, and that's too much for an SME. So our learning is that if we want to educate the SMEs, then we need to be much more efficient and give the information, the knowledge to them very, very quickly. This project finished last year, but hopefully this project will be continued this year. And beside that, we have other EU financed possibilities to educate the SMEs, so we believe that we can continue this activity. If you look at this chart, it shows how many people visited our technology center in the last almost 3 years, and you can see that the SMEs who were part of this project was just a small part of our visitors. So we had a very big interest, and lots of people came to us and just to see these technologies. And based on this big visibility, we decided that we keep this technology center anyway, even if this project has finished. And our mission, the technology center mission, is to have more and more competitive and more than SME in Hungary, utilizing the advantages of the Industry 4.0 technologies. So to achieve this, we offer education and support activities for these companies. Our competencies that we built up during the last years is around the IoT platforms. We learned Siemens and PTC IoT platform, and we have knowledge in several technical areas, which is important for the Industry 4.0 solutions in the university, and we involve different departments to technology center who has this knowledge, like image processing, artificial intelligence, augmented reality, and so on. The technology center provides services like demonstration, education, research and development activities, and consulting services for SMEs. And we have several cooperations. One, of course, is this Living Lab network, and another important cooperation is with the university Bochum. We start a project called Digital Coach. Our goal is to create a new profession, let's say, this digital coach profession. And these digital coaches will be able to educate the people in the companies to these new technologies, because we realize that in each position is very important for the people to understand these technologies and be able to use these new modern systems. It's an interesting research what I show here in this slide. Before we started these projects for the SMEs, we made a survey what kind of developments the SMEs are planning. And we realized that 40% of the SMEs told that they intend to implement new technologies, and 31% told that they intend to implement new IT systems. And we believe these companies are thinking in a kind of Industry 4.0 way. They have this approach, and our technology center intends to support these companies and help them in the investments. And we realized that 52% of the SMEs told that they don't want new technologies. They intend to expand the production capacities by using the old technologies. And our goal is to change this company's mind, because I used to say that if a company has free production line and buys a new production line with the very same technology, then they can increase the capacity by 1/3, because it's the nature of the mathematics. But we realize that usually the production lines are they don't run with 100% utilization, only 30 or 40% utilization. So if a company invests to a technology to improve the efficiency of a production line by logistic or production scheduling applications, then they could easily increase the utilization from 30% to 60%, and they could increase the whole capacity by 100%, not by just 1/3. So we believe that this message should be given to these companies. Let's talk a couple of words about our vision, what Industry 4.0 means, and what we are doing actually in a technical point of view. So we have this definition for Industry 4.0, the digitally supported efficient production systems where the equipment communicate with each other and working together along the value chain. So I has 3 key points of this. I used to say that this is a kind of digital transformation of the industry. It means that all the equipment along the value chain are creating a lot of data. We collect this data and we load this data to different IT systems, and we create a kind of integrated cyber-physical systems, and which allows this digital transformation is mainly the appearance of the IoT technologies, Internet of Things technologies, because the sensors and the data collecting devices became quite cheap and make sense to put these IoT equipments to everywhere in the production systems. Why we think that Industry 4.0 is good? Because we can increase very much the efficiency. The companies who are using these these utility technologies has much bigger growth potential, and it gives agility to these companies because this industry 4.0 technologies makes possible to create customized, tailor-made, or even individual products in a mass production environment. How this digitalization works? We have the manufacturing process, or it can be even a service providing, and we put several sensors to the physical processes to collect the data, and we load this data to IT systems where we can extend this data, transform, visualize, optimize, and based on this optimization, we can intervene in the production even automatically. So what technologies can be used along this process? As I mentioned earlier, just to collect the data from the physical systems, we use IoT equipment, sensors. Several cases, the physical equipment are controlled by PLCs, and these PLCs collects several data internally, the machines or the equipment. So in this case, we have to get the data out of the PLCs. In several cases, it's more difficult than put a new sensor to the system, but it should be solved. In the IT space, we have lots of modern technologies like digital twins, IoT platforms. In several cases, we use cloud-based IT infrastructure to store and collect this big amount of data. We need special technologies like which is called big data solutions, and to be able to get the information out of the data, we use artificial intelligence or machine learning algorithms. In the other side, we have lots of modern technologies to influence the production. We use robots. I used to say that robots are not the result of Industry 4.0, but without robots, the Industry 4.0 cannot work, because the robots are the equipment which can really influence the production, or can do something in the production side. We use 3D printing. It makes possible the individual products, production of individual products or small volume products. And we use virtual reality, augmented reality technologies to make more efficient the production. And it's very important that this Industry 4.0 solution needs a much robust communication because of the lots of data. So we use mainly internet IP-based technologies, but we believe that the appearing of the 5G mobile networks will help a lot for us in the production, because the 5G will be the first commercial service which can provide, for example, guaranteed delivery time. And if we have big sensor networks which creates less data but needs to run with a low power consumption, we can use LoRa and Sigfox network, which are again new technologies. So this was a very short introduction of our technology center and of the our vision about the Industry 4.0. I have to tell you that our technology center is not prepared only for the agri-food companies. So our technologies that we show here are more general. But in the next year, we are planning to create specialized demonstrations for given industries. Thus, the agri-food industry is one of our focus. We believe that the technologies we show here can be used in several industries, with several cases with a very small modification. So we will see this. In the technology center, we show approximately 20 different demonstrations showing the different Industry 4.0 solutions. At this point, I used to say, come with us and walk around and show a demonstration, but I have to say that stay with us, stay at the computer, and with my demonstrators, we will walk around and we will, hopefully, we will show a live video showing the demonstrations. In this scenario, we solve a logistics problem with AGVs, automotive guided vehicles. In the scenario, we have a factory. Factory has two buildings. In the first building, we create parts from raw materials. In the second building, from the parts, we create the product. The internal logistics is optimized and use these AGVs to carry the different parts and products. Balázs, what technologies we use in this scenario?
Okay, so in the AGVs we are using infrared technologies for safety solutions. We have optical sensors for following the tracks of the AGVs, and we are using an infrared technology to position these cars. Positioning is used for optimization of these vehicles, and the data collected from their position is passed to a digital twin. This digital twin is what we are using for the calculation of the tracks and the optimization of these vehicles. So as you can see, we have a physical model here, and this digital twin is the virtual pair you can see on the monitor of this factory. And these data, so the data we collected from the vehicles to position them is passed to this digital twin, and we can optimize the tracks of these AGVs for them to be much effective. So with one vehicle we can achieve at about 34 and 35 seconds of cycle time. This means that to create one product takes 34 or 35 seconds, but if I send in another vehicle, with a little time passing, we can see that this drops down to 14-15 seconds.
One of the biggest possibilities in Industry 4.0 to collect lots of data, analyze this data and visualize. With visualizing the data, we have a good overview of the production, so we see what is happening on the shop floor.
In the next scenarios, we are showing solutions for data collection systems, which are also affordable for SMEs. To the left, you can see a little more complex system here. We have data collection on 3 different levels. On the first one, we are showing useful information for the operators. We have the information of what they are making. We have education for that, and we also are showing them how many workpieces they created from the amount they have to create. On the second level, we are showing useful information for the shift manager. For example, we are showing in each hour the rate of the production. We are also calculating effectiveness of the operators here, and we can also show if there's a pause or something failure in the production. This monitor is going for each of the cells, and lower level one is going for each of the machines. And on the top level, we have a monitor for the entire production plant. This is technically good for the production manager. We can see all the cell informations here, all the machine informations here, and everything useful data is collected and visualized here. So if something malfunctions here, the production is not going as planned, the production manager can react quickly thanks to this application. To the right side, you can see a little more modular but a little less complex system. We can also see different diagrams here. We are showing the state of the production, the status of the production. We can show this in percentages. We can see the number of the faulty products here, and also the rate of the faulty products here. We can see whether the machines were idle in the shift or not, and by only collecting the data that we created a workpiece or not, we can create a lot of useful information here and we can visualize that thanks to this, this data collection, data analysis solution. So in the next scenario, we are showing some basic and some of the most important elements of Industry 4.0. These are data collection, data analysis, and data visualization. We are achieving this here with some cheap sensors, which can be bought from any online shops. This is what we call a Cyberphysical system. So you can see here that we have different sensors here, sensing different environmental parameters. Talking about a greenhouse, we have 3 parameters: temperature, humidity, and brightness. The software of this greenhouse analyzes data, and we also visualize the collected data. As you can see, we can see the collected data from the past. This cyber-physical system means that we have something we would like to create a good environment for. In this specific case, we have a little flower in here, and we'd like to create a good environment for this flower. And we are trying to achieve this with automating this greenhouse. We also have a demonstration here that shows us how this greenhouse uses this automation. So we are collecting data, and we have an environment we'd like to set. And based on the data we collected, we have actuators, for example, like heaters, fans, windows, and by acting to the changes of the environment, this system is creating the optimal environment for this little flower in here, using these actuators. We have a simulated data set here. Now it is a data of 2 days, and you can see how the greenhouse reacts to different changes of the environment. The changes you can see here by visualizing here. So this is why visualization is also very important, because in this case also the operators can see what's happening on the lower levels of production, for example.
Our time is over, but if you just look around, if you just make a picture around the whole technology center, just turn around, you can see that we have several additional demonstrations. So next time, if we can make a real event, you can come to us, visit us, and see our all Industry 4.0 solutions. So that was from Industry 4.0 Technology Center from BME, and thanks for the possibility to show our site.